The goal of the test here at the Slope Lab is to test the latest VIPER mobility prototype in this facility in order to verify requirements. That means we want to check that the system does what it is supposed to do once on the moon. The VIPER test unit that is behind me is a light version of the full VIPER rover. We strip down the heavy components to try to maintain the mass load so that we can drive on Earth, which has a much higher gravity. And we need to do this because the system is designed to go to the moon, where it will be a lot lighter.
We have consulted NASA scientists who have analyzed images and data from previous Apollo missions to determine the distribution of rocks and craters of different sizes over certain areas of the terrain and the shapes and characteristics of rocks that we expect to see on the surface. So what we've done is use that information to recreate a moon-like terrain for the rover.
We're testing our rover capabilities when we go into an extreme sinkage environment. So on the moon, when we're roving, we might encounter areas with fluffier soil, something similar to quicksand. And so our rover has a capability to still make forward progress in these quicksands. We're also testing the ability that the rover has to move in a very special way. It's similar to a caterpillar inchworming motion. So the rover is able to change the distance between its wheels and apply power to the wheels in a very coordinated manner, and that would allow the VIPER rover to get unstuck of this quicksand.
This is challenging for the rover, but it's important to test because we need to better understand and mitigate risks and hazards to the rover. And we have a great team of NASA engineers here to address any risks that we might face.